Well, hello and welcome back to a little bit of geometry. We are in Chapter 1, Section 6. We're describing pairs of angles. Okay, first off, we're going to look at complementary and supplementary angles. Complementary, I remember, sounds kind of like the corner. Corners of rooms are usually built at 90 degrees, so complementary, like the corner. It's my little way to remember that. So complementary adds up to 90 degrees. Now those can be adjacent, like this one, or they just can be two different angles where their values add up to 90 degrees. Like this one, that's 20 degrees plus 70 degrees is 90. So those are complementary angles if they add up to 90 degrees. Supplementary angles. Supplementary reminds me of the straight angle. Supplementary is 180 degrees. Now it doesn't just have to be a straight angle, it could be any two angles whose measure adds up to 180 degrees. That's supplementary. So 3 and 4 here would be on a straight angle, so that has to be 180. It's supplementary. Adjacent angles. Adjacent means next to. Those are two that are next to each other. So they have a common vertex and a common side, but no common interior parts, which means you couldn't have an angle like this, and then, let's see, this angle and this angle. These two have a common vertex, but they also have a common interior part. So those are not adjacent. So these would be not next to each other, and also not adjacent are these two. These are just two different angles. Okay, if I want to identify CAD and RST using the ones that we just had, well, I'll look at their measures and see that 53 degrees plus 127 degrees is 180 degrees. Therefore, these are supplementary. And then here we have BAC, and RST. So let's check that. 37 plus 53. 30 plus 50 is 80. 7 plus 3 is 10. So that gives me 90 degrees. And so those are complementary. All right. Let's have a look at, oh, I think we skipped one. There we go. Finding angle measures. One is a complement of 2, which means angle 1 plus angle 2 is equal to 90 degrees. All right, first thing to note. Okay, and then the measure of angle 1 is 62. So we have to find measure of angle 2. So we can put 62 in right here. 62 plus the measure of angle 2 equals 90. If you want to draw that, you can draw yourself a little 90 degree angle like this and say somewhere in there we've got angle 1 and angle 2. 1 and 2. And so they add together to 90, so I have to subtract 62 from each side, and then I get the measure of angle 2 is 28 degrees. They are supplement, which means angle 3 plus the measure of angle 4 is equal to 90 degrees. Measure of angle 4 is 47. So same thing here. We're going to subtract. This is 47. Measure of angle 3 plus that equals 90. Subtract 47 degrees. And, sorry, this 4 turns out to look like a 9. And we get the measure of angle 3 is equal to 43 degrees. Alright. When viewed from the side, the frame of a ball return net forms a pair of supplementary angles with the ground. Find BCE and measure of ECD. Well, supplementary means that these form a measure of 180. That means when we add these together, angle addition postulant, we know that 4x plus 8 plus x plus 2, together these equal 180. Now careful that you don't try to solve just on one side and subtract and add here. These parentheses in this case are not necessary because it's all addition. So I could just rewrite this 4x plus 8 plus x plus 2 is equal to 180. And now I can combine like terms. 1x plus 4x gives me 5x. 2 plus 8 gives me 10. Equals 180. Degrees, subtract 10 from each side. 5x equals 170. Divide by 5 on each side. And x equals 34. Alright, now that's not a final answer because we're looking for these measures, so now I need to plug that in. So 4 times 34 plus, oh my word, there we go, 4 times 34 plus 8, so 4 times 34 is 136 plus 8 is 144. That is the measure, 44. That is the measure of angle BCE. And then 34 plus 2 is 36, and that is the measure of angle ECD. Alright. Linear pairs. Okay, a linear pair has non-common sides, which are opposite rays. So this is the side that's not in common. They have one common side, and then the non-common side are opposite rays. That means they go in opposite directions on the same line. For vertical angles, the sides form two pairs of opposite rays. So 4 and 5, those are vertical. They're across from each other, and their sides form opposite rays. So this side of 4 forms an opposite side with this side of 5. Same thing here. And then 3 and 6 are vertical angles. Alright, we want to identify all the linear pairs. So for linear pairs, we have 1 and 4. Okay, opposite rays right here, 1 and 4. Measure of angle 1 and angle 4. Those are linear pairs. And then 4 and 5. And measure of 4 and angle 5. Those are linear pairs. And then vertical angles, we only have 1 and 5. Angle 1 and angle 5, because 2 and 4 are not. Even though we have opposite rays here, we don't on the other measure. Okay. Finding angle measures. If we know their linear pair already tells me they add up to 180. The measure of one angle is 5 times the measure of the other. So I can make a little drawing like this. This is 5 times, so I could say 5x, and this is x. And then find the measure. We know that 5x plus x is equal to 180. Meaning 6x is equal to 180, making x equal to 30. And so this is 30 degrees. 5 times 30 is 150 degrees. All right, some things you can conclude from a diagram. Sometimes we look at this and we're like, well, this is 90 degrees. Okay, but it doesn't indicate anywhere that this is 90 degrees. Just because it looks like it doesn't mean we can conclude that. All right, so what can we conclude? We can conclude that A, B, and C are collinear. We can conclude that the angle DBE and EBC are adjacent, and ABD and DBE are also adjacent. We can conclude that B is between A and C. We cannot conclude that AB is congruent to BC, even though it is between. Between does not necessarily mean that it is a bisector. Okay, it looks similar, but it could be 0.1 off. What if this is 5.1 and this is 4.9, right? It would be 0.2 off. Okay, we cannot conclude that these two angles are the same, DBE and EBC. Just because they look the same, we can't conclude that. We cannot conclude that ABD is a right angle from this diagram. Okay, you need more information. You need to have the right angle symbol there. You need to have lines here to imply that they're congruent, or bows here, arches, that would conclude that DBE and EBC are congruent. All right, that, ladies and gentlemen, is all for today. Good times. Check in again next time for another fun lesson in geometry.